Welcome to the Building Web 3 podcast. Today I'm with my good friend. He is the founder and CEO of HyveDA. Quick disclaimer, we app only for informational purposes, and any views expressed by anyone on the show are solely our opinions and not financial advice. Jax and our guests may hold positions in the companies, funds, or projects discussed. Please do your own research. For people that are unfamiliar, and have been living under a rock, can you explain in 1 to 2 minutes what is HyveDA and what are you guys trying to do there?
Yeah, so HyveDA, it's a data availability protocol that is designed just to be a standalone data availability layer for high throughput applications. And that can be high throughput blockchains, but it can also be high throughput decentralized applications such as order books or machine learning networks or AI agents or anything that really is consuming a lot of data. And the way that we built this is in this way that it's completely a standalone layer that can be attached to essentially any blockchain. And obviously we're first doing this with Ethereum because we have this partnership with, or we're using Symbiotic. And with Symbiotic restaking, we enable the security of our network and the security of the DA layer as well through slashing. And that's essentially what we do. So for high throughput applications, so let's take order books, for example, data is a massive bottleneck for them. The more data that they can verifiably publish, the more throughput that they can enable on their own exchange or application as well. And that's essentially what we do. We remove that bottleneck for these kind of applications.
I feel like data availability is probably one of the most misunderstood topics in crypto. They're like, oh, storage, right? So can you explain a little bit, maybe preface with the modular thesis and then go into like what specifically DA is?
Yeah, so indeed, data, this is also something that my team is actually struggling with because it's very easy to get confused between storage and data availability. But data availability basically got introduced as this new method first by Ethereum. It was the first one to propose it. Is essentially this transient storage, which means temporary storage of blobs in a blockchain or in some kind of decentralized network. And it's not storage in the same way that you would have with Filecoin. Like it doesn't guarantee that your file will be able or will be retrievable forever, but it basically guarantees that every node in the network has seen the data and that there's no way that this can really be tampered. So if one of the nodes has not seen the data, then there's still a guarantee that the entirety of the file can be retrieved from the network. So it's basically guaranteed to be available by splitting up this file between the different nodes in the network. And this essentially mitigates this data withholding attack, which means that if one of the nodes in the network is non-responsive or it's malicious or it lied that the data was actually available, then that doesn't mean that the entire file now becomes available or becomes unavailable. If the majority of the nodes or the Byzantine fault tolerant majority of the nodes has the data available, then the data is essentially guaranteed to be available.
Absolutely. And for people that are like, well, why doesn't just Filecoin? Like, why do we even need HyveDA? Why do we need Celestia? Why do we need why do we need a separate data availability solution? Can you talk about some of maybe the intricacies of why these might need to be split out?
Yeah. So with, I'm not sure what the throughput of Filecoin exactly is, but there's one very first principle problem with data availability on stuff like Filecoin or Arweave, is that it's not really built for data availability because data availability is data publishing. So you have your data, such as an order book, to name the same example, to keep it simple, and you publish this on this DA layer or storage layer or whatever you want to call it. And if you were to do that on a Filecoin, then every time someone wants to get stuff from the order book, it wants to see what orders are in there, they need to make a transaction to the Filecoin network to get that data back. And that doesn't really scale. Like if you have an application, you just want that data to be available for everyone to publicly read. And that's what a data availability layer does. It publishes the data, but you don't need to make an extra transaction to get that data back. And that already obviously existed in other solutions. But the problem with those other solutions is that they have a throughput that is around 1 megabyte per second, sometimes even much less, sometimes a little bit more. But for really high throughput applications that are dealing with millions of messages per minute or sometimes even per second, you really need a high throughput data publishing layer so that you can write a lot of data to there, and a lot of users can also get a lot of data back from the network.
Now, talk to us a little bit about, like, we can even just be general about like the adoption of data availability solutions. It's like, I've seen things talked about like, based rollups and like all kinds of different solutions. Obviously, there's Celestia, there's Zero G. Like, talk to us a little bit about like, are people using these? We'll call them like third-party data availability solutions.
Yeah, so the adoption right now, it's really been a trend indeed, like towards the rollups side of things. That's also why it was initially developed by Ethereum Foundation and by Celestia team. But those rollups, they're useful in any kind of rollup. They're useful in base rollups. They're useful in OP stack, Arbitrum, in Elastic Chain. Any kind of like rollup stack can essentially use HyveDA if it wants to have a cheaper blob cost or cheaper transaction cost than if they were to use Ethereum blobs. But what we've also seen is that a lot of these other kinds of networks, so to name again, the order books of the world, DePIN networks, AI agents and AI agent swarms and networks, they also have specific use cases that can really publish from this data publishing layer. And that's something that those are the parties that we're talking to the most right now, that really are looking for this bottleneck for them to be solved. They need to go away from AWS S3, or need to go away from an already decentralized solution that's just not scalable. And they need to have this data publishing layer that scales up to far beyond the horizon.
Yeah, that makes complete sense to me from the like high throughput, like DePIN. Obviously, people know the sponsor of the podcast is HiveMapper, so they're doing a lot of transactions. Now, when I deal with a lot of the DePIN companies, they are almost always on Solana. So now with some of these like higher throughput, solutions like Hive, are you seeing people, more DePIN projects pop up on Ethereum? Are you guys like chain specific? Would even be another question I should ask.
Yeah, those are two separate questions for sure, because I can definitely go into the chain specific part as well. But let's start first with indeed the Solana usage. It makes a lot of sense because Solana essentially enables like this concept of microtransactions, right? Which for IoT devices and DePIN networks is a very valuable thing. What we see right now, we're still in like DevNet, Testnet pushing out, so we don't have anything on mainnet yet. But there's already, from the people that we talk to in DePIN networks, they definitely see this as like a viable solution to build their standalone DePIN network. Doesn't even have to be on a blockchain, doesn't even really have to settle to something like Ethereum. They can just build their DePIN network for just the physical infrastructure to connect and share data in a trustless way. But on top of that, if they were to connect to any kind of blockchain, that's also the beautiful thing about building just a data availability layer and not some kind of L1 or an L2 or sidechain. You can then attach that data availability layer to essentially any chain. So we're starting off with Ethereum, but there might be a future where we connect to other chains. Maybe there will be a chain that is AI specific or specific to DePIN networks. Then it makes a lot of sense to connect this data availability layer to that specific L1 as well as that we can connect it to a sequencer, for example, for OP stack or for Arbitrum stack. We can essentially just take in or make it adaptable to the sequencer. And then for DePIN networks or even L3s building on top of this L2, they can also have just this native data availability or this native blob space within the L2.
Yeah, I've been, ever since interviewing Lewis from Gelato, I've been like stuck between these like two worlds, because I deal a lot with the Solana folks as well, where they're like one chain to rule them all, and more the Gelato thing is like everything in app chain. So what is kind of the thesis that you see relatively developing? I'm assuming it's everything's in app chain based off like most people will need data availability, but like talk to us a little bit about where that slots in and what your thoughts are.
Yeah, I mean, like my opinion on whether it will be app chains or like all these EVM equivalent chains or SVM or whatever. I think it both has places in the world. But there's definitely a lot of use cases for app chains as well. Like if users, they want something that functions really well and that just does what they want as a solution. Take Hyperliquid, for example, this app chain for exchanges, essentially. That got a lot of adoption because it does exactly what users want. It trades at a high velocity. and users can just easily use this in a decentralized way. App chains essentially can be built for anything, whether that's exchanges or AI networks or DePIN or whatever. DA is still a very integral part of that, because with app chains, you still need a data availability layer, or you can build it like an L1, but then you build this external ecosystem, essentially, that people need to bridge over to. While if you build it as an app chain that's composable with all the other app chains on Ethereum or on Solana or on whatever, then you still need a data availability layer to actually publish all of your data to, so that you become verifiable, maybe slashable, and you basically just become decentralized.
Absolutely. And then let's talk a little bit about like how one even builds a data availability layer. I assume it's not just like, I install this SDK and it's easy now. Like talk us a little bit about like how you guys, one, even came up with this idea, and two, like went about building it.
Yeah. So with data availability, there's indeed quite a couple of different solutions. You have like data availability committees. You have obviously Ethereum Danksharding, which is DA built into the L1, and then you have like Celestia, which built on Cosmos SDK. So there's options to build it on an SDK. But what we wanted to build was really this high throughput layer, right? That's was our first goal. So I immediately started with trying to build this as like a standalone layer that is just focused on data availability. So we're very deep into what is the principles of data availability. How do we make it Byzantine fault tolerant? Like all of the technical little whistles to it that make it like this decentralized DA layer. And we wanted to do that actually because we had our own little idea about like a MVP for this decentralized learning network. I won't go too deep into that, but that's essentially we built it because we had a problem ourselves. If you want to build that, you essentially need to follow all of the research that has been done, and then you need to build the layer yourself. So you can use an SDK, so you can build it on Cosmos, but then you would be an L1. So for us, there was no other option than to build it completely from scratch, which meant that we also had to do a lot of research ourselves. And the way that we ended up building this is by following all of the principles when it comes to the erasure encoding and the validity proofs. But we built something pretty unique, which is that we built it all into this DAG structure, which is the directed acyclic graph, which is different from a blockchain structure, and it doesn't have consensus itself. It does have Byzantine fault tolerance and coordination, but it doesn't have consensus. But that meant that basically we use almost no SDKs. Like we use some crates and libraries, obviously from other published open source projects. But we don't use any kind of SDK.
I gotta say, it's always interesting to hear the origin story of companies, because I think if I'm not mistaken, like YouTube started out as a dating app. I believe Discord was like inside of a gaming company, and they like just use the internal app. So it's always interesting when people like roll their own or they try to build something. One of my clients, Enzo, they were building some kind of super app, and they're like, man, all these integrations are horrible. So they essentially built like an abstraction layer for it. So that's quite interesting. So you guys started building this out of necessity and being like, hey, what we wanted to build won't scale unless we have this kind of data availability layer in order to enable very high throughput.
Exactly. Yeah.
Got it. Very interesting. So talk to us a little bit about like what, now that we have higher throughput data availability layers, like what kind of things would be enabled? We could even go back to your initial app idea, or we could talk about like, I think when people talk, they're like AI, gaming, DePIN, like it's going to happen. But like, realistically, like if we could walk through like what is like a DePIN network doing that they need this like super high throughput?
Yeah, it's usually with DePIN networks, DePIN is like this category, right, that encompasses everything, essentially. Everything from like Hive Mapper to like car fleets that are sharing data with each other. So it's a huge category. But essentially what we like to pin it down to is DePIN networks usually deal with thousands, hundreds of thousands, sometimes millions of literal like nodes that are interacting with each other. Sometimes they're super tiny, but they just interact with each other. So it's this huge network, and you don't have that really in any kind of like blockchain yet. Like the committees that are actually producing blocks are usually not bigger than like a few hundred nodes. So DePIN is quite unique in this way, but that also means that they have a lot of data to share with each other. And if you just do this in like a trustless or in like kind of like this trusted manner, where they just send data and they kind of trust that this is the right data, then you can end up in a lot of problems. So what data availability in that category does is this trustless layer where people will publish their data. They can give some kind of proof in that data, whether that's like a ZK proof, like ZK-TLS, or some other kind of proof that the data is correct, plus the actual proofs in the data availability itself that none of that data was changed, and that's the exact data that was submitted by that node. Then you can have this trustless way of one node sharing data with all of the other nodes, which essentially is the most scalable way to actually deal with the data coming from millions or thousands or hundreds of thousands of different physical infrastructure nodes.
And then I think most people, when they think about this and they think quite deeply about it, they're like, well, that's a heck ton of transactions. And when I do a transaction on Ethereum, it's like, I got to pay a lot of money. So is like better data availability solutions, is that reducing the total cost for chains in order to be like, hey, maybe like transactions are going to be like dang near zero? Like what's the kind of knock-on effect of having these like much better throughput?
It is essentially, yeah, it does reduce costs for like a lot of different protocols and networks and blockchains. Because essentially, if you build like an L2, to take it back to that example, all you're doing really with data availability is just storing the raw data, but all of the execution, all of that kind of stuff gets abstracted into this implementer, which is the L2. Same thing with the DePIN network. You're not making a transaction. You're just sending like data or a batch of data. And then it's up to the reader to essentially put the right function over it to execute that into some kind of state. And by separating that data layer from the execution layer, you essentially get to the end result where indeed transactions will be cheaper than if you were to do that all in some kind of monolithic way.
Mm-hmm. Yeah, that makes sense. And then earlier you talked about like erasure coding, and there's like different approaches to data availability, be like, Danksharding, which that's just a hilarious name to me personally. So we got Danksharding, you got like erasure encoding. Like talk to us a little bit about some of the existing solutions, and then like why your solution is superior.
Yeah, when it comes to erasure encoding, right now we just use kind of the same thing that's used in Ethereum Danksharding. And that's just because we were already doing so many unique stuff that we didn't really have time to like research if there was a better way. Like I saw that Bain Capital, the papers when it comes to Zoda and the accidental world computer, like those are probably going to be way better ways to deal with the erasure encoding and the validity proofs of things. But we didn't really have time yet to implement that and look into this if we can come up with an even better solution. But when it comes to what actually makes us better than the other solutions out there, it's one, the throughput. So the throughput is just higher, and we're still completely decentralized and verifiable. So that's a great combination to have. But the second thing is that because we designed it as this standalone layer, it is completely ecosystem agnostic. So if you are an L2 on Ethereum, then you can use HyveDA and still stay Ethereum aligned. But if you want to have it as a L3 on top of an L2, then you can stay completely aligned to that L2 and really become an L3. If you want to just completely stay far away from all the chains, then you can just directly use HyveDA without any chain interference in that. And then you can just scale to the max without ever dealing with any kind of gas costs.
And obviously scaling to the max is something we love here. Talk to us a little bit about, because it seems like your main consumers are obviously going to be like developers, projects like that. Talk to us a little bit about like some of the outreach for people that are unfamiliar with like founding a project. A lot of engineers that used to work with at Google are like, I'm just going to like build a project and people are going to come build on it. And that's unfortunately, no, it's never the case. So talk to us a little bit about like how you guys actually get developers onto the platform and like kind of your outreach there.
Yeah, we indeed build it and they will come. I think it works for some really great projects, and for some it just doesn't work. I think in Web3 it's all about stickiness, to actually have the tools, the outreach, the team to support developers in the right way, so that they stay with your solution and don't just hop on to the next solution that has a better DevRel team. So this is something we are not mainnet yet, so we don't actively integrate with many different projects. but we have a couple of projects that we're working with closely that we are essentially the only solution that currently solves their problem. That we take a lot of feedback from them on what we should actually integrate into our DA. And we actively help them, whether that is by actually giving feedback on their own system, or helping them with toolkits to have easier integration within the DA, or we're even working on like this dashboard so that you can manage your DA as if it was some kind of Azure project that you can also easily manage through like a dashboard. So it's all about like the tooling and the support that you actually give to the developers, which is the two key areas that we focus on.
A question for the developer nerd in me. It's like, a lot of this infrastructure, the decentralized infrastructure, the Web3 infrastructure that people we have on the podcast, it's like, at what point is AWS or like GCP going to be like, you know what? I got to roll my own data availability solution? Or do you think that that's like not really coming, and largely there will be this bifurcation in like Web 2 cloud versus Web 3?
Yeah, I think that's still a long time to go, to be honest, because data availability, like the throughput of us is like 1 gigabyte per second. That's pretty great. But one like mean IO AWS S3 like standalone node that handles 2.5 gigabytes per second at some benchmarks. So that's already higher. And now imagine that there's just not one node in AWS S3, but there's like, I think probably millions actually again with AWS. So that handles like zettabytes or of data every second. So that's obviously way higher than what we can currently do. The end goal is to eventually create this in a completely decentralized way. But I think that's still a lot of different research projects and iterations away until that's actually doable. And I think maybe at that point, it will be good for AWS to also jump into that, or to offer it in their marketplaces. I think that's already done to some degree on Snowflake and on AWS when it comes to like decentralized infrastructure. But I think it's still a few years away. Let's put it that way.
Yeah, I was thinking about that the other day. I'm like, when are we going to see like a GCP roll up? It's like maybe like people just wouldn't trust it. They'd be like, I don't know about that. But I was always wondering about that. So talk to us a little bit about like some of the challenges you guys have faced in kind of building the solution and how you address them.
Yeah, well, the main challenge is because we wanted to build it as a standalone layer, there were quite a couple of problems when it comes to spam control, or like filtering out the spam, because if you have a standalone layer, you don't have the same like transactions that you would have on Ethereum that has a gas fee to it. So you could essentially spam it. Obviously we mitigated that, but that was definitely a challenge. Another challenge is to not make it centralized, and make it verifiable. So we had like a devnet already ready in December that I wanted to ship as a testnet, but then I didn't like that it was not decentralized enough. So we kind of hold it back until testnet is truly decentralized, because it gets quite easy to fall into this pattern where you essentially trust the nodes, or have some kind of trust assumption with the nodes rather than make it truly completely decentralized. And that's the biggest challenge essentially that we have, to make the standalone layer that's not a blockchain, but still make it completely decentralized. And this we also now figured out. We're basically wrapping this up to ship testnet. But now it's a completely Byzantine fault tolerant layer without any kind of blockchain, which is, I think, probably quite unique.
Absolutely. And you mentioned, testnet, you mentioned some upcoming milestones. So what can the community kind of look forward to from you guys, like milestones, any developments that people can see coming down the pipeline?
Yeah, testnet is definitely the biggest milestone. I might be biased because this is literally what we've been working on for months. So it's almost the only thing that's in my head when I sleep at night. But it's definitely a very exciting thing. It will be probably like, to start off the first week, probably a private testnet, and it will become more public. So then we'll have also the first kind of applications that will be starting to test out on how to build this, or how to build on top of the DA. So that will definitely be the first milestone to look forward to. We also got some phenomenal node partners for this. So partnering up with projects like Kiln and P2P. And Instones, etc. So there will be quite some reputable people who will be running the infrastructure, so that we make sure that the uptime is good enough. At least all depends on our software, of course. But I'm confident in that. So that will be like a very cool milestone to look forward to. And probably the next cool milestone will be open sourcing it all. I'm a big proponent of building everything in open source. But right now, obviously, for like strategical reasons, we kept it all closed source. But I'm very excited to share with the Web3 community on what we exactly have been working on the last couple of months.
Very exciting, very exciting. So finally, how can people stay in touch? Where can they follow for updates? Is there a social media, a website, a username you want to call out?
Yeah, we're most active on Twitter. So that is Hive_DA. Definitely subscribe there or follow there, put your notifications on, and you can stay up to date on that way. We also have our own blog on the website, hive.xyz. And yeah, we got a couple of podcasts coming out as well, including this one. So definitely stay in the loop on your account as well to listen to this essentially.
Perfect, man. Well, thank you so much for coming on the podcast. Let's continue building the future of Web3.